In this topic, we are going to be looking at how we multiply fractions. And so today's focus is going to be multiplying a whole number by a fraction using models. So if we look at our first problem, Sasha walked half a mile every day for 5 days. How far did she walk? Use the number line to help you. So this is the first way that we can model with math. If you take a look here and notice what the number line is broken into, the number line is broken into, so I have 0, a line, and then 1. So it's broken into halves. So I can go 1 half, 1 and 1 half, 2 and a half, 3 and a half, 4 and a half, 5. So that's nice that it's broken into those different values. So when we use a number line to help us with model, we're going to start with the 0. Okay, so the first day, she walks half of a mile. Okay, the next day, she walks half of a mile. So we're on 2 days. Day 3, she walks half a mile. Day 4, she walks half a mile. Day 5, she walks half a mile. So if we count, we had 1, 2, 3, 4, 5. So this value right here, it's hard to see with my arrows, but this value is 2.5. So she walked 2.5 miles. So that's one way that I can do it using a number line is I can just start at 0 and then I can just add on a half each day to represent it. Okay. And so the number line, if we go down and look back, it says, how does using a model help us to multiply a whole number by a fraction? It allows us to see how we combined those equal parts. So each day we just added on another 1/2 mile. Okay, let's go ahead and move on to your visual learning. So one model that I showed you guys was really looking at the number line. I'm going to show you guys a different way. So you'll notice here, the other way that we have it is to actually draw out the problem. So if we look at the problem, Joanne wants to make 6 batches of fruit punch. How many cups of orange juice does she need? So she needs to find 6 times 2/3. So when she finds 6 times 2/3 is we can set it up as repeated addition. So 6 times 2/3 would be, if you remember, multiplication is repeated addition. So it'd be 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3. So I can show that using this model. And so if we look at it, we have drawn 1, 2, 3, 4, 5, 6 of 6 boxes, divided it into thirds, shaded in 2 boxes. So when we look at this, it really becomes 6 times 2 divided by 3 because I have the denominator doesn't change, right? But I have 6 2s. 1, 2, 3, 4, 5, 6. So it's 6 times 2 divided by 3 equals 12/3, which if I turn that into a proper fraction equals 4. Okay. The other way that we can do it is we can use the associative property to help us find the problem. And so I can take 2/3, right? 2/3, and I'm going to multiply that by 2 times 1/3. So another way that I can look at 2/3 is I'm really taking a third and I'm multiplying that by 2. So if I go back to 6 times 2/3 equals 6 times 2 times 1/3. Well, the associative property says the order in which I multiply the addends does not matter. And so I can rearrange to where I do 6 times 2 times 1/3. Well, what's 1/3 of 12? 1/3 of 12 is going to be 4. So there's 2 different ways that I can use it. I can actually draw out the model, or I can use the associative property to help with that. Okay, so let's go ahead and go to the 10 times 3/5 says use repeated addition to check your answer, show all of your work. And so if I'm just going to go ahead and I'm going to start by using the associative property way first. Okay, so I'm going to take 10 and I'm going to multiply that by, take out how many 1/5 I have. So I look at the numerator. I have 3 1/5. So it's going to be 3 times 1/5. And so when I do 10 times 3 times 1/5, I'm going to rearrange this. So this is now going to equal 10 times 3. Put that in parentheses to multiply first. Multiply that by 1/5. So 10 times 3, I'm just going to do my work right underneath, is 30 times 1/5. And so we have to look at what is 1/5 of 30. So how many times does 5 go into 30? 5 goes into 30 6 times. So my answer here is going to be 6. So if I want to check that using repeated addition, what I'm going to do is I'm going to do 3/5 10 times. So 3/5 plus 3/5 plus 3/5 plus 3/5. So I'm at 4, 5, 6, 7, 8, 9, 10. Got a little messy. So the 5th doesn't stay the same, right? Our denominator 5 does not stay the same. So I'm going to put that down there. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 3 times 10. So this equals 30/5. 5 goes into 30 6 times. So 2 different ways of solving the problem. Obviously, I don't think I would want to do repeated addition for everything because that is a lot of work. So we're really getting to the point where we can recognize, if you look at the associative property, here I did 10 times 3, here I did 3 times 10. So I just take my numerator, in this case it was 3, multiply it by my multiply it by my whole number, and then divide it by my denominator. So we'll spend some time practicing that as we move on to our next skills. Okay. So, number 1, Micah wants to use Joanne's recipe to make 9 batches of punch. How much orange juice does he need? So, if we go back and we look at Joanne's problem, she needs 2/3 of cup for each batch. So, he wants 9 times 2/3. What is that going to equal? And so, what I said in the last problem is that I can take my whole number, so I can take 9. Make sure I'm on the right thing. I can take 9. I can multiply that by 2. So I have 9 times 2, and I can put that over my denominator. So I multiply the whole number by the numerator, and then I'm going to divide by the denominator. So I'm going to go ahead and finish the problem out. So I have 18/3. Well, how many times does 3 go into 18? 3 goes into 18 6 times, so he needs 6 cups. The other way that I could do that problem is I could do the associative property. So this is what it would look like with the associative property. So let me change colors here. That'll work. So the associative property would be 9 times 2 times 1/3. Okay, so I have 9 times 2 times 1/3. I now rearrange this. So I rearrange where I want to put my parentheses to where I'm multiplying the whole numbers together first. So, and then I'm going to multiply it by the fraction after. So 9 times 2 times 1/3 equals 18 times 1/3, which is going to equal, well, if I have 1/3 of 18, I have 6. So my answer is going to be 6 cups. So either method that you use works. If you want to draw out like we will in 3 and 4 and model it that way to find your answer, absolutely draw it out that way to model your answer. Okay. All right, let's take a look at number 2. It says, explain why 8 times 3/4 is the same as adding 3/4 plus 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 3/4. Pretty sure I got 8 there. So why is multiplication the same as adding the same value over and over? Well, we know that multiplication represents repeated addition. So multiplication represents repeated addition. So that is why it is the same, because they represent the same thing. Okay. All right, 3 and 4, we're going to model, we're going to find each product. We're going to shade the model this time to help. So it's going to look a little bit differently. You're going to shade in. So each model is going to have 2/3. So you're going to take and shade in 2/3. Okay, so I'm going to go ahead and shade in my 2/3. And then I'm going to see how much I have total. So when I shade this in and see how much I have total, I'm going to count my boxes and then divide that by 3. So I have 1, 2, 3, that's a whole. 1, 2, 3, that's a whole. So my answer here is going to be 2. Okay, 2 times 3/5. So same thing. I'm going to shade in 3. So shade in, there's my 3. Shade in, there's my 3. Okay. And so now I'm going to count my boxes, and then every time I get to 5, it's going to equal 1 whole. So I have, with my pointer, I have 1, 2, 3, 4, 5. There's a whole. And then I have 1 left over, so my answer is going to be 1 and 1/5. So that's how I can use it with models, is I can shade it in, and then I need to count every time I get to, here it was 3, every time I get to 5, that becomes a whole, and then I just add those together. Okay, so go ahead and scroll down and we'll take a look at your independent practice. We'll do a couple of these and then I'll assign some problems out for you guys. So in 5 through 7, complete each equation to find the product. I am not going to have you guys do this. To me, yes, it's a very nice visual representation of repeated addition. However, I feel that your time is better used with practicing either the associative property or the other strategy that I showed you, where you multiply the whole number by the numerator and then put it over there and then divide by the denominator to find your mixed number. So if I take a look here, I have 6 times 3/4. What I'm going to do is I'm going to go ahead and I'm going to fill out this one. So I'm going to do 6 times 3, and I'm going to divide that over times 4. Well, 6 times 3 is going to be 18. 18 divided by 4. So 4 goes into 18 how many times? So we're converting this into a mixed number. So 4 goes into 18 4 times with 2 left over. And so if you can, remember, we always need to look to see if we can simplify our product to the lowest terms. 2/4 can be simplified because 2 is the common factor. So it's going to be equal to 4 and 1/2. Next one, we have 16 times 3/8 equals 16 times. So this one's nice. I'm going to go ahead and fill this one out because it kind of works. So 16 times 3. So I'm using associative property here. If you notice, this is going to be associative property. And so it's going to be 16 times 3. So I'm going to go ahead and multiply 16 times 3 out. That's going to be equal to 48 times 1. So I have 48 over 8. 8 goes into 48 6 times. So my answer there is going to be 6. So 500 times 2/5 is going to be equal to 500 times 2 times 1/5. So here's my associative property again. So if you look right here, there's my associative property. And then I'm going to go ahead, I'm going to multiply my whole numbers together first. So I'm going to do 500 times 2. So 500 times 2 is going to be 1,000. And then I multiply that times 1, which is 1,000, over 5. And then we look at how many times 5 goes into 1,000. And so 5 is going to go into 1,000 200 times. So I'm going to have you work on problems 9 through 17 odd. Then you're going to do 18, 19, and then 23 and 24. So I'm going to go ahead and do a second video, and I'm going to go through some more examples. I'm going to go through the even examples of this just to give a little bit more practice. If you would like to watch that other video and work through those problems, you're more than welcome to. Otherwise, you can move into your independent